Hello, everyone. I hope everyone is doing good. And I hope everyone is following and actually understanding the finance topic. We're done with the content. We're going to do an example now. I took question 7 from a particular question paper. And yeah, let's get it done. The laptop 7.1. The value of a laptop depreciates. Depreciates on a reducing balance method. Something very important to note. Do know these words. Do you know what a straight line depreciation is? Reducing balance depreciation is. Yeah. Reducing balance, compound. Straight line, simple. Very simple. At the end of at the rate of 13.4% per annum, calculate the original value of the laptop, right? The original value. By implication we are calculating what? P. Um, yes, the original value of the laptop, given that it had depreciated to this amount, 7 point whatever, over a period of 5 years. So very simple. First and first, your formula, p into 1 minus your interest, and then you have that, right? So we're trying to find the value of p, which of course we know is going to be a bigger value than a. So yeah, let's get the math done. In fact, before all of that, you already see that you have this. Okay, let me do this. You already see here that you're going to have p being a all over 1 minus I to the power of n, right? So to substitute, you have a, which is 7,210. You have 1 minus your interest, which is 0.134 over a period of 5 years, so to the power of 5. And the value we are getting is 7 to 10, 1 plus 0.134 all to the power of 5. The value, what? Oh, is the plus. Yeah, it's the plus. Hey, I was, yeah, because I got 3,000. I'm like, what? Yeah, it was the plus. So now the value is 14802.87. That is the value of the laptop. How much it was before, or at the beginning of year 5. And there, my friend, we are done. Jump on to the next question. Okay. Calculate the effective interest rate if an investment offers a nominal interest rate of 8.2 per annum compounded quarterly. So I still have the formula at the back of my head. It was EFF equals to, here I'll have 1 plus I norm m minus 1. So it's now substitution, right? And substitution, we get 1 plus 0.082 divided by 4 times 4 minus 1. Yes, 4 cos quarterly. 1 plus 0.082, 0.0824 4 minus 1, that is 0.084556, and then that's 1 2, that is 8.1246%. And then, my friend, just like that, we are done. Yeah, we're done. Let's jump on to the next question. All right. So, Alan invested the amount of 20,000 on 1st January 2015 at an interest rate of 10.3 per annum. Oh, compounded monthly. Compounded monthly. At the start of the second year, he deposited, right? At the start of the second year, he deposited that much and then into the same account. But at the interest rate, it increased to 11.5 per annum compounded monthly. At the end of the third year, withdrawal, blah, 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 blah. So, yes. Yeah, so what I said for this kind of question is, I was like, here, your timeline is very, very important. Your timeline is very, very important because it's the one that helps you visualize this thing. Yeah. So, okay, at the end of the third year, so we're at year 3, and then he keeps the money into his account for further 2 years. All right, cool. Let me go back at the end of year 3. So 3, he withdraw certain amount from his account, and okay, he kept the rest in this account for a further 2 years. So 5 years. 5 years. Yeah, these are 5 years. So yeah, T1, 2, 3, S1, this is T0, 1, 2, 3, 4. So T1, T2, T3, T4, T5. Yeah? T1, he invests how much? Plus 20,000. 1, 2, 3. And then it says at the end of year 1, so it's here, he deposited 15,000. 15, 1, 2, 3. And then here at the end of the third year, here he withdrew some cash. I'll say RX. And now let's focus on the interest rate. Compounded monthly, right, at the start of the second year. Okay, so the interest rate from here to here, it was different from the interest rate from here to here. The interest rate here was 10.3% monthly. Here it was 11.5% quarter. Yeah. Oh, also monthly. Nice. Monthly. Cool. I just noticed something I didn't realize. So this, it ends here, and then for the remaining 2 years, right, the interest rate changed to this, right? So from here up until here, we are operating with 16%, 16.8% quarterly. Right. Oh, I missed that. But yeah, they say now, what is the balance of his investment? Got December 31st, 2015. So it's the same year, and like the last day, right? So it's at the end of year one. So you use the formula, number one. Ouch, ouch. So it is 20,000. Interest is 0.103. 12. 12 times 1. Because, yeah, go to your calculator. 20,000. 0.103. 12. 12. The value we are getting is 22,160 and 9. Right, so we are done with this one. Ouch. Let's see what the next one says. I might need this value, so I will just take the whole calculation. Maybe not just the whole calculation, maybe this thing as well. Copy. Yeah, and this will be number 2. How much money to the nearest rent? Okay, how much money to the nearest rent? Did I say to the nearest something this side? Let's see. No. Okay, so how much money to the nearest rent did he withdraw? Or did he withdraw at the end of the third year, given that his final value at the bank, yeah, given that his final value at the bank, what am I saying? Given that his final bank balance at the end of the fifth year was that. So this was the money at the end of the fifth year. So we're still fine. Our timeline, 5 years, we're good. Now, so now realize we go back to the timeline, we're like, at the end of this period, this guy had this much money, and then he invested further 15,000. So we will say maybe A1, maybe let me say A2, because since that was A1 equals to A1 plus 15,000, which is now going to be 22,160.09 plus 15,123. The value we get is gonna be 37,160.09. Damn, I'm kind of smart, eh? That's 7, then that's 1, that's 3. Yeah, so this is how much we have now at the beginning of year 2, right? So now, and then let us remember from the timeline, there will now be, this money will now be invested, or it's put in up until year 3, right? Let's go back. Okay, he deposited this much into the same account, but the interest rate increased to this much, 11.5% compounded monthly. At the end of the third year, that's when he makes a withdrawal. um, yeah, that's when he makes a withdrawal from the savings and kept the rest of the money in his account for a further 2 year at an interest rate of 16.8. So the timeline is still perfect. Yeah, he deposits the money, and then at the end of year three, he withdraws some cash and then leave the rest in the account for with this duration for 2 years. Yeah. So now what we're gonna do, we're gonna take this amount and we will see how much we will have if this money is invested, how much we will have at the end of year three before the withdrawal. A3 P1 I cool. You have 37,000 160.09 11.5 no 0.115 monthly 12 times from year 2 to year 3, that is 1, that is 2, so it's times 2 and we want to see how much that is. 37,160.09 0.115 12 24. So we have the value of 46,718.5. Yeah, that's how much money we'll have. And then we have A3, A4, which is what? Which is 46,718.5 minus X. Let me just say Rx, which is the value we are calculating for. Yeah. If we knew that value, we was gonna take A4 and use it to calculate, the shanties here. So now, okay, now we go back to this formula to say A equals to P into 1 plus NM, right? So now we have been given our accumulated amount, which is it is 30,183.64. So our P is going to be so now this becomes our P. So 46,718.5 minus X, right? The whole thing we are multiplying by 0.164, I think. 8 quarterly times 2. So yeah, it was 2 years and 16.8 quarterly. Let me go back. 2 years, 16.8 quarterly. Cool. We are still on the right track. So now look at this. We're gonna divide by this gentleman both sides. So 1 plus 0.16848 1 plus 0.16848, and of course this gentleman divides this gentleman. Now we have we now have 46,718.5 minus X equals to 30,183,64 divided by 1.06 16848. Now we can say we can say we transpose x, so we have 46,718.5 minus 30,183.641 plus 0.16848 equals to x. Right, so therefore x is going to be how much? Let's see. 46,718.5 minus 30,183.64 divided by 1 plus 0.1684, because it was quarterly, to the power of 8. So we get a value of 24,999.998, and you realize now when we round this off, it makes it 10, 10, 10, 10, 10, 5. So this becomes 25,000. So 25,000 was the amount of money that was withdrawn from this account. Yeah.